Am I audible to you all? Yes, friends. Yes, friends. So it's my pleasure to welcome you all on Unacademy, India's largest learning platform. In today's session, we'll learn about the Solar Orbiter mission. Yes, on our Unacademy platform, you will get structured courses, unlimited access for live and recorded lectures, along with daily live classes and live tests. It's me, Rushikesh Inamdar, guiding UPSC aspirants from last 8 years, and you can follow me on Unacademy, and also you can join our Telegram group using this link. Yes, friends, here is the surprise for all aspirants. So on our platform Unacademy, we are providing 20 books created by best UPSC experts. So these books worth rupees 10,000 you will get free of cost with your 1 year subscription, 2 year subscription and 3 year subscription. This offer is valid till 14th April. Yes, friends, we have mega subscription offer as well. In this offer, you will opt for 1 year plan, then you will get validity till next preliminary examination, that is 2022, and in 2 year plan you will get validity till preliminary examination 2023. So use code RBI Live and this offer is valid till 20th April. Yes, those aspirants are looking for are paid courses. We have plus and iconic courses on our platform where you will get 10% discount after using referral code RBI Live. Yes, you can avail the 10% discount on optional subscription as well after using referral code. Yes, we have combo subscription for your general studies and optional courses where you can opt for 1 year, 2 year and 3 year course. Yes, so in this course as well you will get 10% discount after using referral code RBI Live. Yes, friends, those aspirants are pursuing their graduation, they can opt for iconic subscription. Yes, and those aspirants also planning to start their preparation after their 12th examination, my suggestion to all those aspirants to opt for our iconic subscription. In this subscription you will get all the features of plus course along with personal guidance, expert guidelines, study planner in our iconic course. Yes, we have free test series for all aspirants. Yes, so in this test series we will cover your complete general studies and current affairs. Just you have to use code RBI Live to unlock this free test series. Yes, do not forget to enroll yourself for Unacademy Combat. We are conducting this combat on every Sunday morning 11 a.m. Yes, now this Unacademy Combat is available in Hindi medium also. So enroll yourself using code RBI Live for this Unacademy Combat. Yes, so friends, we'll start today's session. The Solar Orbiter mission. I hope everyone aware about this mission. Yes. So we'll see all aspects and information related with this mission in today's session. Yes. So the Solar Orbiter mission, the Solar Orbiter is a space mission of international collaboration between European Space Agency ESA and NASA. Yes. So the spacecraft was launched from Cape Canaveral on a United Launch Alliance Atlas V rocket in February 2020. So it was selected as the first medium class mission of European Space Agency's Cosmic Vision 2015 to 25 program. Yes, the Solar Orbiter mission was selected as the first medium class mission of European Space Agency's Cosmic Vision for 2015 to 2025 program. Yes, just have a look on the mission. Solar Orbiter mission. Yes, was launched in February 2020. Yes. See the flybars 26 December 2020 Venus, 8th August 2021 Venus, 26 November 2021 Earth, 3rd September 2022 it will flybys Venus. Yes, in 18th February 2025 again Venus. On 24th December 2026 Venus. So the Solar Orbiter mission is joint venture or mission by NASA and ESA. On 17th March 2028 Venus, 10 June 2029 again Venus, yes, and on 2nd September on Venus again. Yes, yes. Now friends, so the spacecraft was launched on February 2020. So this is the first mission that will provide images of the sun's north and south poles. Yes, using a suite of 6 instruments. Yes, on using suite of 6 instruments on board that will capture the spacecraft's view. Yes, it is a 7-year mission and will come within 26 million miles of the sun. Yes, So it will be able to brave the heat of the sun because it has a custom titanium heat. Yes, it has a titanium heat shield coated in calcium phosphate so that it can endure temperature up to 970 degrees Fahrenheit. Yes, this mission will be able to brave the heat of the sun because it has custom titanium heat shield coated in calcium phosphate so that it can endure temperatures up to 970 degrees Fahrenheit. Yes. Now before that, we'll just have a look on anatomy of the sun. Yes. See, these are the sunspots. Yes, darker, cooler areas on the phosphate with concentration of magnetic field. Then prominence. Yes, this is the large structure, often many thousands of kilometers in extent. Granulation. Yes. So granulation, small short-lived grainy features that cover the sun. Yes. Caused by thermal currents rising from below. Then chromosphere. Yes. The chromosphere, this layer above the photosphere. Yes. This layer above the photosphere where the density of plasma drops dramatically. Then photosphere. Yes. So this visible surface of the sun, photosphere. Then transition region. Yes. This is transition region. So thin irregular layer of separates the relatively cool chromosphere from the much hotter corona. Yes. Then flare. This part is flare, which is sudden release of energy in the form of radiation. Yes. Then this is convective zone. So rapid heating of plasma creates currents of heated and cooled gas. Radiative zone. Yes, energy created in the core diffuses slowly through the plasma. This is the core. Yes. So where the sun generates its energy via thermonuclear reactions. Then this outer part is corona, the sun's outer atmosphere, which extends millions of kilometers into outer space. Coronal mass ejection. Yes, vast eruption of billions of tons of plasma and accompanying magnetic fields from the sun's corona. And after that, solar wind. Yes. So solar wind, a continuous stream of charged particles released from the corona. Yes. So this is the anatomy of the sun. Yes, the details have been referred or source ESA. Yes. Yes, now it's in summarize like convention zone, prominence, radiactive zone core, corona, phosphere, sunspot, chromosphere, and coronal hole. Yes. Now, if we are talking about this solar orbiter mission, it is a 7-year mission. Yes. So, 19 ESA member states are Austria, Belgium. Yes. So there are 19 member states of ESA are Austria, Belgium, Czech Republic, Denmark, Finland, France, Germany, Greece, Italy, Ireland, Luxembourg, the Netherlands, Norway, Poland, Portugal, Spain, Sweden, Switzerland, and the United Kingdom. Yes, these are the 19 member states are the part of ESA. So, solar orbiter follows the Ulysses spacecraft. Yes, the Ulysses spacecraft, another collaboration between ESA and NASA. Yes, that launched in 1990. Yes. So the solar orbiter is on a unique trajectory that will allow its comprehensive set of instructions to provide humanity with the first ever images of the sun's poles. Yes, this trajectory includes 12 close approaches to the sun, bringing the spacecraft within the orbit of Mercury. Yes, to study the sun and its influence on space. Yes. So, what makes solar orbiter unique in this combination of high resolution images and in situ instruments? So, while solar orbiter won't venture close enough to penetrate the sun's corona or crown-like outer atmosphere, it will maneuver into unique out of plane orbit that will take it while solar orbiter won't venture close enough to penetrate the sun's corona or crown like outer atmosphere, it will maneuver into a unique out of plane orbit that will take yes. Well close approaches to the sun. So after that, the spacecraft will join NASA's Parker Solar Probe. Yes, launched 1.5 years ago and will work closely with it. Yes, the spacecraft will join NASA's Parker Solar Probe, which launched 1.5 years ago and will work closely with it. So together, they will provide a never before seen global view of the star. Yes, the DO will make new multi-point measurements possible. So this will be useful for tracking how flows from the sun develop and change. Yes, this will be useful for tracking how flows from the sun develop and change. So at various points, the two missions will make coordinated observations. Yes. Yes. So now we'll see what are solar flares. Yes. So it is a large explosion of magnetic energy in the sun's atmosphere. Yes. Which causes an intense burst of increased brightness. So solar flares is a large explosion of magnetic energy in the sun's atmosphere which causes an intense burst of increased brightness. Flares occur in active regions around sunspots. Yes, during solar flares, the sun releases burst of energetic particles that enhance the solar wind that constantly emanates from the star into the surrounding space. Yes, when these particles interact with Earth's magnetosphere, they can cause magnetic storms that can disrupt telecommunication networks and power grids on the ground. Yes, so when these particles interact with Earth's magnetosphere, they can cause magnetic storms that can disrupt telecommunication networks and power grids on the ground. Yes. Now after that we'll see the what is corona. Yes, as we have seen in the picture, this is the part, the sun's outer atmosphere, which extends millions of kilometers into outer space. Yes. So the solar corona is the outmost layer of the sun's atmosphere. Yes, the outermost layer of the sun's atmosphere that extends million of kilometers into outer space. Yes, corona's temperature is more than a million degree Celsius, which is orders of magnitude hotter than the surface of the sun, a cool 5500 degree Celsius. Yes, after many decades of studies, the physical mechanism that heat the corona are still not fully understood. So, but identifying them is considered the holy grail of solar physics. Yes, so after many decades of studies, the physical mechanisms that heat the corona are still not fully understood, but the identifying them is considered the holy grail of solar physics. Yes. After that, we'll cover sunspots. Yes, so sunspots are areas that appear dark on the surface of the sun. Yes, which is on photosphere. So they appear dark because are cooler than other parts of the sun. Yes, sunspots are cooler than other parts of the sun. Yes, however, the temperature of a sunspot is still very hot, around 6500 degrees Fahrenheit. Yes, so the temperature of a sunspot is still very hot, around 6500 degrees Fahrenheit. So, photosphere is a visible surface of the sun from which is emitted most of the sun's light that reaches Earth directly. Yes, the sunspots are relatively cool because they form at the areas where magnetic fields are particularly strong. Yes, these magnetic fields are so strong that they keep some of the heat within the sun from reaching the surface. So, magnetic field in such areas is about 2500 times stronger than Earth's magnetic field. Yes, magnetic field in such areas about 2500 times stronger than Earth's magnetic field. Yes. So, they typically consist of dark region called umbra, which is surrounded by a lighter region called penumbra. Yes, umbra and penumbra. So umbra, which consists of a dark region and which surrounded by a lighter region, is called penumbra. Yes, in every solar cycle, the number of sunspots increases and decreases. Yes, so the current solar cycle, which began in 2008, is in its solar minimum phase when the number of sunspots and solar flares is at a routine low. Yes, so the current solar cycle, which began in 2008, is in its solar minimum phase when the number of sunspots and solar flares is at a routine low. Yes, see the picture of these sunspots. Yes. So now we'll see solar flares are sometimes accompanied by a coronal mass ejection CME. So this coronal mass ejection are huge bubbles. Sorry. This coronal mass ejection are huge bubbles of radiation and particles from the sun's corona. Yes, which is outermost region of the sun's atmosphere, and they explode into space at very high speed when the sun's magnetic field lines suddenly reorganize. Yes. So the coronal mass ejection are huge bubbles of radiation and particles from the sun's corona, and they explode into space at very high speed when the sun's magnetic field lines suddenly reorganize. Yes, they can trigger intense light in the sky on Earth called auroras. Yes, some of the energy and small particles travel down the magnetic field lines at the north and south poles into Earth's atmosphere. So, there the particles interact with gases in the atmosphere, resulting in beautiful displays of light in the sky. Yes. Oxygen gives off green and red light. Nitrogen glows blue and purple. Yes, the oxygen gives off green and red light, whereas nitrogen glows blue and purple. Yes. So, the aurora in Earth's northern atmosphere is called aurora borealis or northern lights. So, in southern counterpart is called aurora australis or the southern lights. Yes. So, just see the pictures to this orbiter mission. So thanks for ESA to provide such informative videos to people to study about this solar orbiter mission. So now see the sun, these are the solar flare. So through solar winds, these are the magnetic shield. Then this is auroral oval, and this again magnetic field. Yes, magnetic shield, magnetic field, and this is auroral oval. Yes. Now after that, we'll study solar cycle. Yes, now we'll learn about solar cycle. So the sun is huge ball of electrically charged hot gas. This charged gas moves, generating a powerful magnetic field. The sun's magnetic field goes through a cycle called the solar cycle. Yes, every 11 years or so, the sun's magnetic field completely flips. So this means that the sun's north and south poles switch places. Then it takes about another 11 years for the sun's north and south poles to flip back again. So the solar cycle affects activity on the surface of the sun, such as sunspots, which are caused by the sun's magnetic field. And as the magnetic fields change, so does the amount of activity on the sun's surface. Yes, one way to track the solar cycle is by counting the number of sunspots. The beginning of a solar cycle is a solar minimum, or when the sun has the least sunspots. So over time, solar activity and the number of sunspots increases. Yes. The middle of the solar cycle is the solar maximum, or when the sun has the most sunspots. As the cycle ends, it fades back to the solar minimum and then a new cycle begins. Yes. Now we'll see the solar cycle 25. Yes. So the scientists from NASA and the National Oceanic and Atmospheric Administration NOAA have announced their predictions about the new solar cycle, which is called solar cycle 25. Yes, which they believe has begun. So the key findings of the solar cycle 25, the solar minimum for solar cycle 25 occurred in December 2019. Yes, scientists predict a solar maximum will be reached by July 2025, which is middle of the solar cycle. And this solar cycle will be as strong as the last solar cycle. So which was below average cycle but not without risks. Yes, which was below average cycle but not without risks. Yes, see the picture. Two thousand 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Yes. So, see the extreme exploration with Solar Orbiter and Parker Solar Probe. Yes. So this is solar orbiter, and this is polar solar probe. So the solar orbiter which has 42 million kilometers to the sun at closest approach, 10 instruments to observe the turbulent solar surface, its hot outer atmosphere, and change in the solar wind. Yes, combination of in situ and remote sensing observations. So first images of the sun's poles, the key to understanding the sun's activity and solar cycle. Then Parker Solar Probe. It has 6.2 million kilometers to the sun at closest approach. Yes, 4 instruments to study magnetic fields, plasma, energetic particles and solar winds. Yes, which flies through the sun's inner atmosphere to trace how energy flows through the corona. Yes. So now we'll see the impacts of solar cycle on Earth. Yes, the solar eruptions can cause lights in the sky, which called aurora, or impact radio communications. Yes, extreme eruptions can even affect electricity grids on the Earth. Yes, solar activity can affect satellite electronics and limit their lifetime. Radiation can be dangerous for astronauts who do work on the outside of the International Space Station. Yes. So radiations can be dangerous for astronauts who do work on the outside of the International Space Station. Then we'll see what is solar minimum and maximum. So one way to track the solar cycle is by counting the number of sunspots. So the beginning of a solar cycle is a solar minimum, or when the sun has least sunspots. So over the time, solar activity and the number of sunspots increases. Yes, the middle of solar cycle is the solar maximum. Yes, the middle of the solar cycle is the solar maximum. So when the sun has the most sunspots, as the cycle ends, it fades back to the solar minimum and then a new cycle begins. Yes. Then we'll study significance of solar orbital mission. Yes, it will observe the sun with high spatial resolution telescopes and capture observations in the environment directly surrounding the spacecraft to know how the sun can affect the space environment throughout the solar system. Yes, it also intends to give a better understanding of how stars can affect the space environment throughout the solar system. Yes, the spacecraft also will be the first to provide images of the sun's poles. Yes, the mapping of sun's pole could allow for the first time to observe the concentrated source of solar wind that permeates our solar system. Yes, the solar wind is the mixture of charged particles that are highly concentrated at the poles and beam through our solar system. Yes, affecting satellites and electronic devices on Earth. Yes. So the mission will also study magnetic environment. Yes, magnetic environment around the sun, which in turn will provide information about sun's 11-year solar cycle. Yes, and its periodic outpouring of solar storms. Yes. This mission, the solar orbiter carries 10 instruments. So 3 of which will help to survey how sun's surface changes over time. Yes, the observations will shed light on the other stars, which providing clues as to the potential habitability of worlds in other solar systems. Yes, the findings will help scientists better predict space weather, which can disrupt communications. Yes. Now we'll see. The solar orbiter will sit around answering 4 top level science questions. Yes, this solar orbiter will set about answering 4 top level science questions like what drives the solar wind? Where does the coronal magnetic field originate from? Second, how do solar transit drive heliospheric variability? How do solar eruptions produce energetic particle radiation that fills the heliosphere? And how does the solar dynamo work and drive connections between the sun and the heliosphere? Yes. Now after that we'll see Parker Solar Probe. Yes, it is a planned NASA's robotic spacecraft to probe the outer corona of the sun, humanity's first mission to the sun's corona. So on its journey to explore sun's atmosphere and the solar wind. Yes, it will probe, determine the structure and dynamics of the magnetic field at the sources of solar wind, trace the flow of energy that hits the corona and accelerate the solar wind. Yes, determine what mechanisms accelerate and transport energetic particles. Yes. Now after that we'll see Aditya-L1 mission. Yes, what is meant by Aditya-L1 mission? So the Indian Space Research Organization ISRO is preparing for its scientific expedition to study the sun. Yes, Aditya-L1. It would be placed into a point in space known as the L1 Lagrange point. Yes, Aditya-L1 will be ISRO's second space-based astronomy mission after AstroSat. Yes, AstroSat, which was launched in 2015. So Aditya-1 was renamed as Aditya-L1. The Aditya-1 was meant to observe only the solar corona. Yes. So now ISRO is preparing for its first scientific expedition to study the sun, Aditya-L1 mission. Yes. So after that, come to the solar orbiter journey around the sun. Yes. So this solar orbiter mission was launched on 9th February 2020 EST and 10th February 2020 on GMT. Yes, so the mission was launched in February 2020. Yes, the close approaches to the Sun in Feb 2021 within 0.5 AU. Yes, average distance between Sun and Earth measured by unit AU. October 2022 within 0.3 AU. So after that, see the first polar pass less than 70-degree latitude in March 2025. Then first polar pass less than 24 degrees latitude in January 2027. Then first polar pass less than 30-degree latitude in April 28. And polar pass less yes, that is 33-degree latitude in July 2029. So the first polar pass greater than 17 degrees latitude, March 2025. First polar pass greater than 24 degrees latitude, January 2027. Then first polar pass greater than 30 degrees latitude, April 2028. And polar pass greater than 33 degrees latitude, July 2029. Yes, already we have covered this through video as well. So the 300 million kilometer maximum distance between Earth and the solar orbiter, 16.5 minute maximum time for a ratio signal to travel one way between Earth and the solar orbiter, 22 orbits around the Sun, November 2021 start of main mission, whereas December 2026 expected start of extended mission. Yes, it's all about the solar orbiter mission. So friends, just have a recap what we have covered in today's session. Yes. Solar orbiter mission is a space mission of international collaboration between European Space Agency ESA and NASA. Yes, the spacecraft was launched from Cape Canaveral on a United Launch Alliance Atlas V rocket in February 2020. Yes, this orbiter mission, solar orbiter mission, was selected as the first medium class mission of European Space Agency's Cosmic Vision 2015-2025 program. Yes. Then, this is the first mission that will provide images of Sun's north and south poles. It's a 7-year mission. Yes, then we have covered autonomy of the Sun. Yes, where we have covered sunspots, prominence, granulation, chromosphere, photosphere, transition region, flare, convective zone, radiative zone, corona, coronal mass ejection, CME, and solar wind. Yes, already we have covered the detailed information about all these terms. Yes. So there are 19 member states of European Space Agency like Australia, Belgium, Czech Republic, Denmark, Finland, France, Germany, Greece, Italy, Ireland, Luxembourg, the Netherlands, Norway, Poland, Portugal, Spain, Sweden, Switzerland, and the United Kingdom. Yes, the solar orbiter follows the Ulysses spacecraft, another collaboration between European Space Agency and the NASA that launched in 1990. Yes, then we have covered the information related with the solar orbiter mission. Then we have covered what are solar flares. Yes. Then what is corona? Then we have covered sunspots. Yes, so in every solar cycle, the number of sunspots increases and decreases. Then we have covered coronal mass ejection, CME. Yes. Then we have covered solar cycle. So every 11 years or so, the sun magnetic field completely flips, and the sun is a huge ball of electrically charged hot gas. Yes. So the sun's magnetic field goes through a cycle which is called solar cycle. Yes, the solar cycle affects activity on the surface of the sun, such as sunspots. Yes, the beginning of a solar cycle is a solar minimum, and when sun has the least sunspots. So the middle of the solar cycle is the solar maximum, when the sun has the most sunspots. Then we have covered solar cycle 25. Yes, the scientists from NASA and National Oceanic and Atmospheric Administration NOAA have announced their predictions about the new solar cycle, which is called solar cycle 25. Yes, the solar minimum for solar cycle 25 occurred in December 2019. So the solar cycle will be strong as the last solar cycle, which was below average cycle but not without risks. Then we have covered the extreme exploration with solar orbiter and Parker solar probe with comparison. Yes. Then we have covered impacts of solar cycle on Earth. Yes, so the solar eruptions can cause lights in the sky called aurora and impact radio communications. So solar activity can affect satellite electronics and limit their lifetime. Then we have covered solar minimum and maximum. Then we have covered significance of solar orbit mission. Yes. So the spacecraft also will be the first to provide images of the sun's poles. Yes, solar orbiter carries 10 instruments, 3 of which will help to survey how sun's surface changes over time. So the findings will be help scientists better predict space weather, which can disrupt communications. Then we have covered top level science questions, which will set about answering by solar orbiter after the completion of mission. Then we have covered Parker Solar Probe. Yes. So this Parker Solar Probe will determine the structure and dynamics of the magnetic field at the sources of solar wind, which trace the flow of energy that hits the corona and accelerates the solar wind, determine what mechanisms accelerate and transport energetic particles, and after that we have covered Aditya-L1 Mission. Yes, this is Indian Space Research Organization, ISRO preparing for its first scientific expedition to study the sun, which named as Aditya-L1. So this Aditya-L1 will be ISRO's second space-based astronomy mission after AstroStar. Yes, AstroStar, which was launched in 2015. Yes. So Aditya-1 was renamed as Aditya-L1, and the Aditya-1 was meant to observe only the solar corona. Yes, so it's all about the solar orbital mission and various components and information related with the solar orbital mission we have completed. Yes. Also we have covered the journey of solar orbital around the sun. Yes. So that's it for today's session. Friends, see you in the next lecture with new topic. Till the time, you can join our Telegram group using this link, and also you can use referral code RBI Live to get 10% discount. So please like, share and subscribe videos of Unacademy. And suggestion to all aspirants, those who are appearing for upcoming prelims in June 2021, they should start solving question papers, multiple choice questions, and also do not forget to enroll yourself for our free test series by Unacademy. Yes. So friends, keep studying, keep learning. Thank you. Take care.